Converse. Everybody say Converse.
Converse.
Where have we heard Converse before?
Shoe.
The shoe, right? Give me a thumbs up if you've heard of Converse shoes. Okay, does anybody know what the term Converse means?
Like
Mix? Okay, oh, converse. Yeah, if I'm conversing with you guys, that means we're talking, kind of. Converse, though, pronounced that way, means a little bit something different. Do you guys know how long Converse, the shoe company's been around? They've been around a long, long, long time. What's that?
1800.
1955? I think maybe around there, maybe before. If you look back at like really old pictures from the NBA, like when Wilt Chamberlain was playing, every single player is wearing Converse. And then nowadays we know technology is different. I can't even imagine playing basketball in Converse. I'd definitely break my ankles. Yeah, LeBron's are probably better for you. But back in the day, every single basketball player wore Converse. Even like soccer players would go out there and wear Converse. Okay, and the reason why is because Converse was one of the first shoe companies that made leather-soled shoes. Or, sorry, rubber-soled shoes, not leather. Up until that point, what do you think the soles of your shoes were made of? Not leather. Close to cardboard. Wood. Wood. If you've ever seen like men's dress shoes, they've got wood bottom soles. Because back in the 40s,
like boots.
yeah, like boots, 30s, 40s, 50s, everybody dressed, you know, and you look at old-timey pictures, everyone's wearing suits and dress shoes. So Converse was one of the first companies that actually made like a sneaker with a rubber sole. The term Converse basically just means opposite. So the company Converse took what all these other shoe companies were doing and they just did the complete opposite, right? They created a shoe that was designed for a specific purpose that was against what all these other shoe companies were doing.
They're built different.
They were one of the first companies that is quite literally built different. And the shoes are built different too. And that led the way for now all these shoe companies use rubber soles. They've expanded the technology to the point where Converse are not as, you know, technologically advanced as some of these other shoe companies. But they were the pioneers. So the converse of the Pythagorean theorem just means the opposite of it, right? I'm not given two sides and I have to find the third number. I'm given three sides and I'm asked, is this a right triangle? And we're going to figure out if it is or not using the Pythagorean theorem. It's really, really easy. So we're going to be given three sides of the triangle. We're going to plug them into the Pythagorean theorem to verify if they form a right triangle or not. For example, if I'm given 6, 8, and 10 as my three numbers, just like in the regular Pythagorean theorem, the first thing we have to figure out is which side is C. That's the one that matters what I'm plugging into. So between 6, 8, and 10, what would my longest side be? I'll ask that again. Between 6, 8, and 10, what's the biggest number? Hey, 10. That means my C has got to be 10. Is 6 going to be my A or my B? Or does it matter? Doesn't matter. So I'll call this one A, I'll call this one B. I have to call 10 C though. That's the important part. All right? So for A squared plus B squared equals C squared, I'm going to plug in 6 for A. I'm going to plug in 8 for B. And I'm going to plug in 10 for C. Right? I don't have any missing side lengths like we're used to seeing. What is 6 squared going to be? 36. What about 8 squared? 64. Thank you. And 10 squared? 100. Everybody with me so far? Okay. What should we do next? Add. What is 36 plus 64? 100. So I'm left with an equation that reads 100 equals 100. Is that true or is that false?
True.
That is true. If I have $100 and you have $100, we have the same amount of money, right? So because this statement is true, this is a right triangle. This is a right triangle. All right? Seems easy enough, right? Let's see what the converse of that's going to be, the opposite. Alicia?
You don't have to like do the square root.
Nope. No square root at all. The only reason we need to do the square root is because I end up with c squared, and I need c all by itself, right? So to reverse that squared, I square root. But here I don't have any variables. I'm just plugging in and checking. It's like if I end an answer with x equals 6, I can plug it back in and check my work. That's basically what it is. We're just checking work. So on the flip side of that, if I have a triangle with side lengths 12, 9, and 16, I want to see if this makes a right triangle as well. That should not be there, but what is the longest side here between 12, 9, and 16? 16. So I know 16 is going to be my C. Does it matter which of these 12 and 9 is my A and which one's my B? No. I'll call 12 my A and 9 my B. Doesn't matter. Now I'm going to plug them in. 12 squared plus 9 squared equals 16 squared. Everybody cool on how we plug those in? Yeah? What is 12 squared equal to? What is 9 squared equal to? What is 16 squared equal to? 256. Good. I'm glad we're memorizing some of these. All right. Now 144 plus 81. 56, 25. So that's 225 equals 256. That's what we end up with here for this statement. Is 225 equal to 256? No, it is not. If I have $225 and you have $256, we don't have the same amount of money. Everyone with me? So because this statement is false, this is not a right triangle. How we doing with that? Good? We might have a new record on shortest notes, 7 minutes. Pretty straightforward, right? And the worksheet doesn't even have it back because I don't know why. Maybe I messed it up. So this is real easy mathematically, but I want you to visualize why this works and why it doesn't. Okay, so up on the board I have 5 pieces of tape, all at different lengths. This yellow one is 13 inches. The orange one is 5 inches, the green one is 12, purple is 3, and the black one is 4 inches, okay? Can I get a volunteer that wants to come up here and see if they can make a triangle with these pieces of tape? Come on up, Ryan.
Wait, all of them?
No. Just pick 3 of them, and you're going to put them together end to end, and you're going to see if it makes a right triangle. Okay, starting out with the 5. Very nice. Going with the 3.
Wait, what? Okay.
That's all right. You'll see.
This is harder than I thought.
Okay. And the 4. Look at that. Does that look like a right triangle to you? Thumbs up, yes. Thumbs down, no. What do you think? Yeah, absolutely. Great job, Ryan. Thank you. We see this little square down here. Boom, boom. There's my right triangle. So she picked 3, 4, and 5. This is 3. This is 4. This is 5. If we use this method, we can plug them in like this. Right? What is 3 squared again? 9. What is 4 squared?
16.
What is 5 squared? What's 9 plus 16? 25. Look at that. That works out. Raya absolutely got it. Okay? Yeah, that's right. You're like that. 25 equals 25. That's true. This is a right triangle. Does that kind of make sense? Yeah. Someone else want to come up and try with some different lengths? Raya, come on up. Let me erase this real quick. Let me put these back. This was the 4. No.
I believe you.
This was the 3. This one was the 4. And then the 5. All right, so it can't be a 3, 4, 5. See if you can get a right triangle with 3 different ones. All right, starting off with the yellow one, the 13. It's a good start. Going for the 12. You may have to adjust the second one when you throw the third one down there. You can't see that yellow at all. That's why. It's kind of hard to get up, I know. Okay, making our right angle right there. You got it. There we go. Perfect.
Oh shoot. Goodness.
One of those will definitely work. Nice. Okay. Hey, look at that. Pretty good. That looks pretty good. Let's see. It looks like a right angle. Great job, Rhea.
It's like to the side.
It looks like there's a little right angle. I mean, this isn't exact, so that looks like a right angle. This was what? 13, 12, and 5? Let's try it out. 12 squared plus 5 squared equals 13 squared. What's 12 squared? 144. What's 5 squared? 25. And what's 13 squared? What's 144 plus 25? 169. Look at that. Great job. Perfect. Absolutely right. Now I'm going to show you a non-example, right? Because those two worked out great. But why do these ones down here, why don't these ones work out? Well, let me try. Oh, whoops, there goes the 12. Which three lengths, just shout it out, would not make a right triangle? We know right away would not make a right triangle.
3, 4, and 13.
You said 4 and 13 and 8.
8.
Oh, 3. 4, 3, and 13. Ah, I see. Good. This is a good one for us. Let's see. I got 3. Put it right here. 4. Go kind of wide out like that. And then which one's my 13? The yellow one, right? Yeah. Look at that. Can I even make a regular triangle, let alone a right triangle with those two distances? No, right? And this is what we talked about on Monday. This is 3, 4, and 13, right? So if you remember from it was the triangle introduction. Oh, review of triangles, right? Note sheet number 11 for this. The C, the hypotenuse, has to be longer than the other two, right? But the legs, when combined, have to be longer than the hypotenuse. What's the combined leg length here? 7. Is that longer than the hypotenuse? No. So that is a triangle that we physically cannot construct, right? Let's say I switched out the 3. Let me take this 3 out of here and plug in something that would work like 13. So this is 13, 12, and 4. If I have 12, oops, that's not a 12. 12, 4, and 13. Will this make a triangle? Well, what's 12 plus 4? 16. That is longer than the hypotenuse, so this will definitely make a triangle. The question is it going to make a right triangle? I don't think so, but let's find out. If I've got this guy right here, I'll make him like, it's kind of hard to do with this. It's got to be. Oops. There you go. Something like that. Pretty close. Does that look like a right triangle to you? No, not really. Let's verify it though. This is 4, 12, and 13, right? What's 4 squared? 16. What's 12 squared? 144. And 13 squared is 169. What's 144 plus 16? 160. Is 160 equal to 169? No. But see how these two numbers are close together? That means this is almost a right triangle. So we can see this angle here is probably like 95 degrees or something. This one's probably like 80 degrees or something like that. So it is really, really close. That's definitely wrong. But it's really, really close to a right triangle. Not quite there because the Pythagorean theorem doesn't work out like that, okay? Quick show of thumbs, how much sense is that making? Does that visual help at all? Yeah? Okay, perfect. The work is much easier than trying to figure out all that tape stuff. So once you get it, go ahead and get started. Just make sure you're keeping track of which one is C. That's the only one that really matters where you're plugging it in. Yeah, give me 1 second. This really should not take too super long. So if you've got some other stuff from another class to work on, today would be a great day to get going on that. Missing assignments. Lots of missing assignments that are due on Monday. Tomorrow is the last day you will see me before the test. So missing assignments got to get done quick. making sense? Good. C is the longest one. Don't matter. As long as the A and B are the two smallest ones, it doesn't matter which is which. You're welcome. Yes, let me grab you some. Can I get headphones? Yeah, give me 1 second. We got a couple things on the plate. What's up, baby? Oh, you're done? Oh, you can go ahead and take that back. Do you need a pass back?
Why'd you give us so many?
Do you have that bigger guy?
I'm not doing
Yeah.
two extra.
Those ones are tricky too. That whole thing. I was looking at it. Nobody lives. I don't like that. So if it's like competing and stuff, it won't be a part of that next. Yeah. Well, all that crazy stuff you're doing, no. You're gonna leave that in separate.
I didn't expect somebody to match the energy.
Yeah, you'll be good.
You'll be great.
Thank you.
See, that's why you're my
Have a good rest of your day, AB.
Bye, AB.
Okay. Talk about it. Just talk to us. Oh, I still have. AB. AB.
And then she's gonna want to buy like 20 other things, so that's what happened last year.
Wait, I'll ask you about it.